Thank you, thank you. So yeah, as announced today, we're going to talk a little bit about powering and scaling the next generation of competitive play, and a technology that is now part of the Azure team. Words like container technology and scaling and orchestrating of game servers is something I'm going to talk about and show that off with a few slides. So if you're packaging a binary or a game server file, you can do that very easily via a specific technology we've built that basically is a smarter way of orchestrating a binary file on a agnostic infrastructure. Of course, in that infrastructure is mainly the Azure infrastructure we use, and a mix of binaries that can go to dedicated servers for also other environments. Let's put it in a simple way. So the industry itself shouted out a few dirty words that I'm not allowed to use of my CTO, but Gameye is basically a Docker for high-performance game servers. And what that basically means is that we don't use Docker, because that's not the right technology to deploy binary as a game server on, because it lacks a lot of things. So what Gameye did is build its own orchestrator and its own container umbrella word to deploy game servers around the world. So this is something we spent the last 3 years on in a basement and building this technology from the ground up. Why did we do that? Well, we wanted to get to the end result, and that is of course higher quality. The orchestrator itself is a smart orchestrator that deploys containers on a infrastructure that's consists of Azure, but also other providers, and it makes full use of the hosting fleet and the resources itself. We'll talk a little bit more about the differences of VMs and containers itself. We've built an API on top of this, and of course the main reason is to save time for integration for game studios, and a few other abilities to make sure that we get to the end result of higher quality. I mentioned VMs a little bit already, so if you're used to spinning up virtual machines, that's great. But what we wanted to achieve in our infrastructure is make sure that we deploy matches. So if you're building a session-based multiplayer game, let's give an example, Apex, which you can hear the noise on my side, PUBG. You want to spin up matches as fast as possible. You can do that on a dedicated server, you can spin up virtual machines around the world, but if you want to get as close to the end user as possible and you have a massive infrastructure, you want to do that as close to the end user. And so what we've built is a different way of spinning up containers. I will explain a little bit more how that works later on. So when you start using the API of Gameye as a game studio, something you get out of the box is of course scalability. The orchestrator itself makes a few decisions on deploying the container. It can deploy on different locations around the world, but in this example we'll look at the UK. So you go into a lobby of a game, you say I would like to play the game, you're being matched with other players. At that point you will make, the matchmaking will make a decision, where do I deploy? And those things could be based on capacity, of course, that could be based on the ping itself, is it as close to the end user as possible, but also the cost. So it's a smarter way of deploying containers this way, and it can scale up and scale down based on what's happening in the matchmaking. To dive in a little bit more on the matchmaking itself, so we work with game studios that are very early stage and are starting to work on their the next session-based game. What we got from the industry a lot is that they would like to work with third-party ways of matchmaking, because you have different words or different matchmakings that could be skill-based or could be location-based. So we work with third-party matchmaking as well, so you could use PlayFab matchmaking or any other matchmaking. Then within that matchmaking you would call an API call to our core, and the core is Gameye, and we'll make the decisions on where to deploy the container anywhere in the infrastructure. So third parties could be even third parties like Faceit or PlayFab doing the matchmaking. You will join the queue and that will make a decision on the different clusters we have around the world. Once you have an infrastructure up and running and you're using the API of Gameye, one of the things that are being neglected a lot is making sure that all the game servers have the latest binary files all over the world. Well, you can do that the easy way, just by uploading it to a CDN, and the CDN will make sure that the game server files are all over the world being distributed. But that will take a lot of time. So we've done a lot of testing against AWS GameLift or other providers in the world. So what we do is we've built a technology that's a mix of CDN that brings the needed binary file to our clusters, and then within the clusters we use a specific peer-to-peer technology that looks at the different game servers, looks at each other, and makes sure that the latest binaries is in all environments. So the difference we will have is like when you distribute a binary all over the world that's in different servers, we've tested with files like from 10 gigabytes of Counter-Strike. Will take up to 5 minutes all over the world to have the latest files on all the game servers. So for instance, we did a test in comparison with AWS GameLift versus Gameye. The same binary took the entire GameLift infrastructure 40 minutes versus our own clusters that was 5 minutes. So that's a big difference. When you're bringing out a new binary, a new file, and the client's updated, you want these game servers to be updated as well. And time is of an essence, especially for gamers. They want to start gaming again as fast as possible. This is all done on top. On top, we build an API which you can use with one basic reason, and that is game studios want to focus on building games and not being busy with figuring out which infrastructure they should use, figuring out where to deploy on, how to deploy these things. And that's something we take out of the equation. You just use our API to, we give the binary to our API, and then the API is ready to start deploying matches all over the world. Using the API is very easy. If you're a developer, things like this will be recognized. You just can start using different SDKs we've built in different environments. And starting the API itself is as easy as just getting an API token ready to go and start building your application. So on the client side itself, and start integrating. The API has a few specific characteristics and different tools, especially when you're building a competitive game. In that competitive game, real-time statistics are very important. So let's say you build a game like PUBG, you need real-time statistics coming out of your game server. And what we've built on top of our container technology is a sort of a translation tool. So the SD out can translate basically the SD out of a binary, and then the game studio can decide what does this data do, how do we need to structure this, and what kind of JSON file do we need to structure the data. And that has a specific reason, of course, in a later state, but there are a few different tools you need for a container to work with. You need to know the state of the container. So what is the container doing? Is the match being launched? Is the match in a pause? Is it broken? Do we need to launch it again? Or is it the end of the match? So all of this can be done with the API, and it's being streamed real time through the API back again to the end user. A very simple thing to do if you need to deploy a container, this is all you need. So I need a match somewhere in the world, these are the specifics, give it to me now. And this is all done after the matchmaking itself. You can then use the third-party matchmaking or use our matchmaking that's already baked into the API. We work with different esports companies all over the world. Where our history is actually esports. So we work with different esports platforms who are using our technology. And we're now translating this technology to game studios. But what we want to do as well is bring that back to esports again. So if you're building a competitive game, you also want to make sure that your audience, your fans, are able to do things with your game. And that is running custom matches. So PUBG has something that's as a custom match that's being done, for instance, with Faceit. They can run custom matches. But what you also want to do is give that data to other community providers like OPGG, which is quite a big thing in Asia. You want them to give the real-time data of user profiling so that they can do something with that. So what the game studio can do now is decide who do we give this data to and why do we give this data to. But the game studio itself, the publisher itself, is still in total control of what's going to happen with that data. So if something is being done wrongly, then they can pull the plug on the API. The API is of course the main thing we've built, but we know that a dashboard is very important. But the dashboard itself is basically a visual translation of what you can do on the API. So no worries, everything that you can do in the API is also seeable and doable and usable in the dashboard itself. So you can zoom into what's going on in my infrastructure, which matches are running all over the world. You can filter those, you can zoom into those, what's the live data going on, and figure out what the issues are. We even have a dashboard where you can look into and see what the game server actually is doing, CPU-wise, memory-wise, are there any latency issues? And that's also the data we use to feed our orchestrator, to deploy to different locations all around the world. We have different SDKs and packages you can start using now. Of course, the Azure Marketplace is one of them. But if you're, even if the fan base you're using, it uses PHP, I know it's a horrible language, but small forums or clans or that sort of stuff would love to use that API as well and start working with our match tool as well. So that's basically in a nutshell what we're doing at Gameye. It's a container orchestrator for session-based competitive games and to deploy on a worldwide infrastructure.